Hello, everybody. This is Mr. Fluharty, and we are starting part 3 of a unit on chemical reactions. Now, one of the key skills, it's really a skill, and it's a math skill. One of the key skills that you need to learn about chemical reactions is balancing chemical reactions. And the only way to learn this is to practice. So, in this video, I am going to show you how to do these types of problems. Okay, but before we do that, I am going to get rid of my picture because it'll give us more room. Okay, there we go. Okay, so these are chemical equations. Notice that on the left, we have the reactants. And on the right, we have the products. On the left, you can see here, we have two different substances. If you look at the periodic table, the first is aluminum, the second is hydrochloric acid, H with C, capital C, lowercase l. Those come together and they form aluminum chloride, which is an ionic substance, and hydrogen gas. Okay. Now, this is not balanced. So in order to find the actual chemical reaction or the actual recipe on how to make hydrogen gas and aluminum chloride, we need to balance it. Now, to do this, I'm going to make a table. The table is going to have reactants on one side and products on the other side. Okay. And I'm going to list all of the types of atoms in this reaction. So we have aluminum, we have hydrogen, and we have chlorine. Maybe I can get rid of, oops. Yeah. I don't know why it's doing that. Okay, let me fix this. Reactants and R. Okay, so now we count atoms. So on the left of the arrow, the reactant side, you can see there's one atom of aluminum. So I'm going to put a 1 there. We have one atom of hydrogen in that formula. There's one hydrogen and one chlorine. So I'm going to put a 1 there and a 1 there. On the right side, we also have one aluminum. But look at this chlorine. It has a subscript 3 here. So we have 3 chlorines. And in this hydrogen molecule, we have 2 hydrogen. Okay, so if you look at this table, it looks like we start out with 1 aluminum atom and we end up with 1, and that's good. We start with 1 hydrogen atom and we end up with 2. So that's a problem because we can't just magically create a hydrogen. We start out with 1 chlorine and we end up with 3. So that's another problem. So at this point, you have to figure out a way to balance, to add. It looks like we have to add atoms to the left hand, the reactant side. The way we do that is with coefficients, and that's the only way that we're allowed to do this. Okay, so you have to make a decision. What are you going to balance first? Well, I think I'm going to balance the chlorine first since it has the largest number. So in order to balance the chlorine, I have 3 on the right, so I'm going to put a 3 here as a coefficient. Okay, so what that means is that on the left, instead of 1, now you have 3 chlorine. But that also changes the hydrogen. Instead of 1 hydrogen, you have 3 hydrogen. So now, if you look at it, the chlorine's okay. The only thing that's wrong right now is the hydrogen. You've got 3 on the left and only 2 on the right. So now, how do we balance that? Well, what I'm going to do is I'm going to find the lowest common multiple of 2 and 3. What's the lowest common multiple? What about 2 times 3? That's 6. Again, like I say, this is a real mathematical procedure here. So if I want to use this idea of the lowest common multiple, I am going to, what is 2 times what equals 6? 3. So I'll put a 3 there. What that does is it makes this 2 a 6 on the right. Okay, and then I'm going to, instead of a 3 there, I'm going to erase that 3. And I'm going to put a 6. So that means this 3 becomes a 6, and this 3 becomes a 6, because now we have 6 hydrogens and 6 chlorines. So now the hydrogens are balanced. But now the chlorines are not balanced. So what times 3 equals 6? A 2. So I'll put a 2 there. And that changes this 3 on the right because there's 2 of these aluminum chlorides. 2 times 3 equals 6. So there's 6 chlorines. But now there are 2 aluminums. And I think we're almost done. The hydrogen is balanced. The chlorine is balanced. The only thing that's not balanced is the aluminum. And you can see if I put a 2 there, now this aluminum is balanced. So right here, this is the recipe for making aluminum chloride and hydrogen gas. In order to make aluminum chloride and hydrogen gas, you need 2 atoms of aluminum, and you need 6 molecules of hydrogen chloride, and then that will make 2 formula units of aluminum chloride and 3 molecules of hydrogen gas, and everything's balanced, and that will work. Okay. Now, of course, we don't really talk about atoms and molecules. I mean, they're just too small. So it's a lot easier to talk about moles of molecules. So instead of talking about individuals, we're going to talk about 6 times 10 to the 23, or moles of materials. Okay, let's do another one. Again, first step, make your table. This is the reactant side. This is the product side. And then I'm going to list all the atoms. Aluminum. I'm sorry, this is actually called arsenic. AS is arsenic. Then we have chlorine. And that's it, right? Just arsenic and chlorine. Okay, on the left, we have 1 arsenic here. On the right, we have 1 arsenic. On the left, we have 2 chlorine. On the right, we have 5 chlorine, right? That's what this little 5 means. Okay, I'll get rid of that, just so you're not confused. Okay, now, how do we balance this? Well, the arsenic is already balanced. I'm going to make that A a little bit taller just to make sure you understand. That's a lowercase s. So arsenic is okay, but the chlorine is not. We got 2 on the left and 5 on the right. So how do we balance these? Well, let's find the common multiple between 2 and 5. Well, that's 10, because 2 times 5 equals 10. That's the lowest common multiple. So what times 5 equals 10? Well, a 2 does. So I'm going to put a 2 there. And that's going to change this 5 to a 10. And that's going to change this 1 to a 2. Okay. On the other side, what times 2 equals 10? Well, 5 does. So I'll put a coefficient 5 there. And that's going to change this 2 to a 10. Okay, so what do we do to this on the left-hand side, on the reactant side? What do we do to make these 2 atoms of arsenic? Well, let me tell you, this is illegal. If you put a little 2 down here, that is illegal. You're not supposed to do that. Okay, so what I can do, though, is I can put a 2 out in front, and that changes that to a 2. So this is arsenic is a metal, but if we react it with a nonmetal, right, a metal with a nonmetal, with chlorine, you can make this compound arsenic chloride. Arsenic chloride is rat poison. And it's tasteless. And actually, it was the favorite poison for wives who wanted to get rid of their husbands around the turn of the 20th century. Because back then, police departments, they didn't have a chemical means, an easy chemical means to figure out what was going on when the husbands were dying from this rat poison that wives were giving them. Anyway, let's keep going. Painful death. Anyway, so here's another one.